All right, we're in section 2.4 where we're going to use postulates and diagrams. So um, we're going to kind of dive into more more proofs in the second half of chapter 2. And one of the things that we're going to look at is a series of postulates. If you remember, by definition, postulates um, are statements that don't need proof. They exist without a proof. And we have a series of postulates here that are um, towards points, lines, and planes. So we got point, line, and plane postulates. So I'm not going to read them all to you, but we're definitely going to use a majority of these postulates as we move forward, not only in this section, but in future sections to come. So here, I guess what we can do is basically what these postulates and also with the diagrams is basically we have to be able to interpret which postulate uh, the diagram is trying to illustrate. So right here it says if we have points A, B, and C, then it looks like we have a plane that contains A, B, and C. So this postulate that illustrates this diagram is postulate, because if you read postulate, it says through any three non-collinear points there exists exactly one plane. So we have postulate 8 here, and it says through any three and non-collinear, just like the definition is telling us, any non-collinear, there exists exactly one plane. So postulate is what that particular diagram is trying to illustrate. Here it says use the diagram to write examples of postulates 9 and 11. So I'll just read what postulate 9 says. It says a plane contains at least three non-collinear points. So we have two planes apparently. We got plane Q and plane P. There's no dot next to it, so it doesn't establish a point. So they're telling you that's the name of those two respected planes. So if you look here, if you have plane P, it appears that there are only 2 points on that plane in this example. It's only uh, y and x. All right, so those are the two that are on that plane. Um, I look here on Q, looks like V is part of Q, Y is part of Q, and W is part of Q. So we have the at least three non-collinear points in plane Q, and those particular points are again V, Y, and W. So postulate 11, it says intersection of plane P and Q is what? So with 11 it says two planes intersect, their intersection is a line. That's the definition that was on the first page. So again, if I look at those two intersected ones, it intersects right here. And since there's only one point that's connecting that one, so the only name right here is this, so it's going to be line B. So line B is what intersects plane P and plane Q. So here it says which postulate allows you to say that the intersection of line A and line B is a point. So if I look back here, um, it appears like it's postulate 7. Postulate 7 states that if two lines intersect, then their intersection is exactly 1 point. So postulate 7 helps us with that. So I looked at from there. All right, here it says write examples of postulate 5 and postulate 6. So they have the definition here. It says through any two lines there exists one line. So, you know, if we use the diagram up here, just to erase some things. So using the diagram up here, it says, so again, repeating what postulate 5 says, through any 2 points there exists exactly one line. So if you look at line A right here, so this is line A, 2 points pass through it. So line A passes through points X and Y. So if you look here, here's X, there's Y, it passes through point A. And then it says a line contains at least 2 points. So kind of on the kind of piggyback off of what postulate 5 says, we can say that line A contains points X and Y. Okay. All right, so here it says concept summary. It says when you interpret a diagram, you can only assume information about size or measure only if it is marked. So you can't make the measurement. The only thing that we can assume things is what stuff is given to us. So we have this diagram here. It's a little bigger than the picture, so it makes it kind of tough to kind of see this, in the video, but hopefully you have your notes in front of you and you can kind of go from there. So the top portion here, it says what can we assume? All right. We can assume if we look at this entire diagram, it seems like every point is on plane P. And so since all the points are on plane P, we can make the assumption that they are coplanar. Uh, we can make an assumption. Let's see here. Let me kind of illustrate this. Let's find out where A, H, B, AHB. We could also say that AHF are a linear pair. So 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 AHB, we could say that that is, yeah, angle AHF. Actually, it also says that here. So let's try another one. Well, actually, no, let's keep it with that. Angle AHF. All right, I can assume that. Boom here, boom here. Yes, for sure. Here it says AHF and what are vertical angles. So here's one angle. The vertical angle would be right here, so it would be BHD. So angle BHD are vertical angles. We can assume that. Here they're saying points A, H, J, and D are, let's see here, looks like, are they all on the same line? A, H, J, and D, they're all in the same line. We can assume that they are collinear. And then finally, it says AD and BF intersect at, and it looks like point H right there. All right. Next, I'm just going to do some erasing. There's some things that we cannot assume. So here it says blank, blank, and blank are collinear. We can't assume that apparently 3 points are collinear. So actually, I cannot assume that E, F, and G are collinear. Could they be? Possibly, but there's no other information that's telling us that. So E, F, and G, I can't assume that they're collinear. I also can't assume that they're not collinear either. Uh, I cannot assume that uh, line BF and line CE intersect. So here's BF is right here, CE is right here. Are they parallel? I don't know. So so we can't assume that they will intersect because they don't intersect in the diagram. We can only go by uh, what it's telling us. Finally, the last thing here, it says blank and blank do not intersect. Uh, well, well, yeah, it's the same thing. So that would be BF and CE. So just like we don't know if they intersect, we don't know if they do not intersect. So there we go. Uh, some angle assumptions that we can't make. We cannot assume that angle BHA is congruent to angle CJA. So look over here, BHA is right there. We cannot assume that CJA is congruent. We can't assume that because we don't know. It's kind of off the same thing of whether they intersect or not. We can't assume that. Or we can't assume that line AD is perpendicular to line BF, or in that same idea, we can't say the measurement of angle AHB equals 90 degrees. We can't assume that. If they were telling us that um, something was 90 degrees or something that was parallel, we could make some other assumptions and then go from there. But in this particular instance, we can't assume those things. All right, so here now, what they would like us to do is sketch a diagram showing that RS, so it's a line segment, is perpendicular to line TV, intersecting at point X. So first step, they want us to draw line segment RS. So I go here, I go here, I got R, I got S. Draw a point X between it. So I'm just going to draw an X between it. Next, it says draw TV through X that is perpendicular. So I got to go here, make my line. So this is X, this is T, this is V, and because it's perpendicular, I got to make it that right angle there. So that is everything that they told us, from the sketch diagram fits that particular um, parameter. Okay. So, but if we look down here, it says if the given information indicates that Rx is congruent to XS, how would that diagram change? So if I look over here, you know, if Rx, if this was supposed to be equal to this, you would probably draw it where point X would be in the midpoint, or you would draw it in the middle. Or again, you draw it in the middle. So again, your diagram would kind of look like this. So I got R, I got X, S, here's point X, and then here's TV, and here's here, and then I can make my, my hash marks, you know, stating that those two items or those two line segments are congruent. Okay, so that's how that diagram would change a bit. Here it says, which of the following statements cannot be assumed from the diagram? So it says E, D, and C are collinear. Um, can we assume that? Yeah, we can, because they're right on this line and they have the line. We can assume that. So we can assume that. Here it says intersection of B, D, and E, C. Is there an intersection there at point D? I can assume that. Here they're saying BD, which is right here, is perpendicular to EC. Now, in this particular instance, there is no, 90-degree, angle that represent it or anything that says 90 degrees. So in this case, I cannot assume. And then here it says EC is perpendicular to plane G. All right, again, this is another one where we cannot assume, because just like in the previous statement, there is no 90-degree angle mark. I mean, if like there was like a 90-degree angle mark like this, then uh, we could make that assumption, but in this case we cannot. It says, with no right angles marks, you cannot assume what? All right, so basically, what I said here, we can't assume that um, BD is perpendicular to EC and EC is perpendicular to plane G. So you could just fill that in. Last thing here, can you assume that BD is the intersection of plane F and plane G in the diagram above? So BD, which is right here, it's contained in both planes. Yes, we can assume that. And that is being able to use postulates and diagrams. Hope this helps.